Hello everyone, this is going to be the video for the second chapter of this Cisco course, Configuring a Network Operating System. We are Jason Crimali Soyula and Luis Fernando Diaz Hernandez in the team. Our home networks are usually connected to many devices. This device is usually what is called a router. A router is actually 4 devices in one. These devices consist of a router that forwards and receives data packages, a switch which connects devices with network cables, a radio transmitter which is actually the one responsible of sending the waves, the radio waves, that connect us wirelessly to the internet. And the last device we have is a firewall appliance. This one stops and lets us choose what traffic we want in our device. Every router has its own operating system, otherwise known as the OS. This operating system is usually saved in the flash memory, which means it is not lost when it is powered down. When the router is turned on, the OS is copied from the flash memory to the RAM memory because it's faster. And so we can change the settings of this operating system through usually a web browser, through what we know as a WI, a user-controlled interface. When updating our routers, we must make sure that the technical specifications of our router are compatible with the new software. This means that we have enough space and the hardware is actually able to run the new version of the OS. Our routers have different functions. These are all included in the OS of each router. These might be providing network security, addressing an IP address to physical and virtual interfaces. The IP is really important because it is an identification of what device and where is the device connected to the network. It enables interface-specific configurations to optimize connectivity of the respective media. This means that it lets us look at videos and images and songs at the same time because it gives us the right type of connectivity-specific configurations. It gives us routing and it gives us quality of service technologies. It also supports us in managing network technologies. We have two ways of accessing this iOS: through the WI, which is a web browser, and through the SLA. This is more hardware dependent since it depends on accessing it through a console, that means another computer maybe, an SSH, which can be an internet cable, or an auxiliary port, which is usually known as a telephone port. When we connect through a console, we can connect a cable and it lets us enter console commands as if we were in the command screen on our computer. It's recommended that we place a password and that we put the router in an area which is not easily accessible by physical means, so that someone we do not want accessing our router cannot simply plug a cable in it and change our settings. The next one, known as Telnet or SSH, requires us to connect to the internet, and it requires us to be connected to the internet. We require networking services for this to work. We need an IP address too, and it is also recommended that we use the SSH or Secure Shell Protocol with more password and encrypted data so that not anyone can change our settings. The last one is the auxiliary port, which is usually a telephone cable. This does not require an internet connection, and we can set a password also so that it doesn't get changed by people we don't want it to be changed. It is important to understand how the iOS hierarchical structure is constructed. We can or can't do many things depending on where are we sitting in. By sitting in, I mean which type of rights we have. The default mode our router gives us is a user exec command. This lets us ping, lets us show some information, lets us enable the device, and that's more or less it. We can't do a lot of things. We cannot set passwords and we cannot change IP addresses or some other configurations that are related to more complicated network configurations. If we have rights, we can change our actual position to the privileged executive command. This gives us the opportunity to configure our router, lets us reload our settings, that means saving any changes we make, and it lets us enter sub-configurations of our router. Some of the things we can do in this configuration are giving a host name to the device we're configuring. It lets us enable its secret IP routes, that means routes we only can see. It lets us change the name of the device. It lets us set passwords to things we want to be secured, so that people who we don't authorize cannot access these devices. And we can also make some messages appear if someone tries to change our settings. This means that it more or less gives us full control of what our device is gonna do. We have interface commands which are related to what the user does. We got line commands which are more related to entering passwords and some other input to change more things, and the routing engine commands, which are actually specific info on the router or the connection. So if we are in the first step, we can use this symbol for our commands. It does not require any type of authentication. If we are in the privileged exec commands, we are going to use this other symbol to access our commands. One of the modes we can access to from the privileged exec mode is the global configuration mode. This lets us change specific service or interface configurations. Here we're going to see an example of how our interface more or less looks like and how we can change from the normal exec mode to the privileged exec mode. In this example, we did not input any password, as you can see, because we did not set any. So if there was a password, we would have needed to input it too. In this other example, we can see how are we going to configure a terminal. After we input the command configure terminal, we get the following messages. After that, we write the interface VLAN 1. Do not think about this one. This just means that we're going to configure the interface of the network called VLAN 1. What we want you to look at is the next command, the exit command. We are not going to change anyone in interface VLAN. We're just exiting from that interface, and the next exit is going to take us out of the configure terminal. As so, we can go back and forth between each module. The general rule for writing all our commands is the following. We first write our prompt, which can be seen as the name of the device, then the command we want to do, which can be, for example, ping or show something. Then we're going to leave a space, which is important so that the computer does not confuses what we're writing, and then we're going to write the keyword or our argument. This next example is going to show you one specific special command you are going to use. It's for configuring a host name of a device. So after accessing our interface, we write configure terminal so that we get to the options of configuring our device name switch. Now that we are there, we're going to write the command #hostname, which means we are going to access the hostname of this device, and then we're going to write the name of the device we want. In this case, we named it SW-Floor1. After we press enter, you can see that it does not longer say switch. It now says the name of the device, and it also gives us a prompt telling us that we have successfully configured the switch hostname. We highly recommend you that after seeing this video, you go in the documentation page so you can look at all the commands that there are, so you can do all the things that you want, because they are really extensive and they are not covered in the module. In this configure terminal, where we just change our hostname, we can do a couple things. We can enable a password, which means that anyone who wants to go into the privileged exit mode is going to write that password if they want to access. We can enable a secret. This is kind of difficult to understand because this one limits access to devices over the internet. It is recommended to set every password we can, so we do not get any unexpected users of our internet connections. The last important thing we can do is configuring a banner. A banner means that any user that tries to modify these settings is not going to be permitted to do so, and they will get a message. You can look at an example in the Cisco module, which actually has a little bit more documentation on how to do this, but you can also look it in the documentation online. After we have done all changes, we're going to write the name of the device, the correct prompt afterwards, and the reload keyword. This will ask us if we want to change or not our settings. If we click yes, or if we write yes, sorry, we are going to change our settings. If we don't, then our device is going to stay as it was. Once we get the hang of this, we're going to introduce another concept. What is an IP address? This address is used to communicate with other devices, and every single device has to have one. The most common type of IP address are the IPv4. It is in a notation called decimal notation, and it is represented with 4 decimal numbers between 0 and 255. They provide information on the location of the device, and thus they are called logical in nature because they give us geological data of where we are located. Aside from our IP address, each IP address or device has a subnet mask. This subnet mask more or less tells us what particular network or large network the device is connected to. It's like an internal number for your house. So you have your outside number for people to send you packages, and then you have your inside number inside, for example, your colony. That is a subnet mask. Now, IP addresses, and it's important to note, do not necessarily need physical hardware associated to them. You can make a virtual machine inside your own hardware that has its own IP address. In this type of cases, this virtual interface, as it's known, does not have any hardware device directly associated with it. Another important thing to know, talking about hardware devices, is that the configuration of cables can change what type of machine we're going to need to use. Some type of cables can affect the amount of data and the speed we need. And so not every device and not every cable is going to be able to send information anywhere. If we want to send a lot of information to, for example, Africa, we're going to need better equipment than those that we would need to just send information across an office. In things as an office, for example, Ethernet is going to be the most commonly LAN used. For a cable to connect devices using an Ethernet port, the cable must have a RJ45 connector. Continuing with our example of the office, not every IP address is set manually. There is this thing called the Dynamic Host Configuration Protocol, or DHCP, that allows devices to have IP information automatically configured. This means that when you connect to the internet with your device, it is going to have all the information it needs directly sent to it and set to it without you having to do anything. This happens, for example, in our school, where we just turn on our device and we can connect to the internet with just 1 or 2 clicks, and that's it. That's a dynamic host protocol. So if you want, you can also set manually your IP address. When doing so, you have to take into account what type of device you are using and if the configuration of the network which you are trying to access to has some kind of security protocols. Also, and another important thing to take into note, so that you do not fall into IP addresses conflicts, is that the IP address that you are going to assign to your device is not already in use. This covers the chapter and its basic concepts. If you have any remaining doubts, please do not feel afraid to ask, leave a comment, or look at the module in the Cisco page so you can find more exercises and more interactive explanations of what we've been talking about. Thank you for your patience.